Okay, let's do two more examples. For the example on the left, I'm going to start with right-hand side this time because to me it's easier to simplify secant and tangent and get to cosine sine rather than the other way around. Okay, so let's start from the right-hand side, which means we've got secant theta plus tangent theta. This can be rewritten as 1 over cosine theta plus sine theta over cosine theta, which means I'm going to get 1 plus sine theta all over cosine theta. Now there's a little trick. When I get to this point, I'm looking over here, look here, and then I'm going to see that, hey, in the result that I want to arrive, I need 1 minus sine theta to appear somehow. But if I look over here, 1 minus sine theta isn't here yet, isn't here. Okay, so what you need to do is you need to actually make it appear. So what happens is I'm gonna go, okay, so that's the same as 1 over sine theta cosine theta. I'm gonna force that thing to appear, multiply by 1 minus sine theta over 1 minus sine theta. Okay, so notice here that I'm not moving anything from left hand side to the right hand side or vice versa. All I'm doing is multiplying by 1, because this is 1. Anything divided by itself is 1. I'm not changing that fraction. But if I do that, I have forced out that 1 minus sine theta that I need. Alright, so this becomes this 1 minus sine theta all over cosine theta over 1 minus sine theta. Notice that in the denominator, I never ever really expand the brackets because chances are things are going to cancel out. On top, you're going to get difference of two squares, which is 1 minus sine squared theta over cosine theta times by 1 minus sine theta. And what is 1 minus sine squared theta? Well, it is cosine squared theta, which means this equation then becomes, the right-hand side becomes cosine squared theta over cosine theta times by 1 minus sine theta. The square and the cosine will cancel out, and you're going to end up with cosine theta all over 1 minus sine theta, which is the left-hand side. Okay. Looking at the question on the right-hand side, I am going to start from the left-hand side of this equation, okay, because it's a little bit more complicated. It is easier to collapse something rather than to expand it out. So left-hand side, I know that this is sine theta over 1 plus cosine theta plus 1 plus cosine theta over sine theta. Now, if you look on the right-hand side, you realize this is one thing. Alright, so basically my intuition will tell me then, okay, let's combine the two fractions into the same common denominator. So this becomes sine theta times by sine theta plus 1 plus cosine theta times by 1 plus cosine theta all over sine theta times by 1 plus cosine theta. Okay, now this means that I've got sine squared theta plus this thing is 1 plus 1 plus 2 cosine theta plus cosine square theta all over sine theta 1 plus cosine theta. Right, this is the same as sine squared theta plus cosine square theta plus 1 plus 2 cosine, this is the cos theta all over sine theta times by 1 plus cosine theta. Now, notice that my eyes went straight into sine squared and cosine squared because I know this part. If I combine them, it's going to give me 1. Well, 1 plus 1 is 2, so the numerator becomes 2 plus 2 cosine theta over sine theta 1 plus cosine theta. And the top can be factorized. 2 times by 1 plus cosine theta all over sine theta and 1 plus cosine theta, and you will see that these two will cancel out to give you 2 over sine theta. Okay, so this will give me 2 over sine theta, which is in fact 2 cosecant theta, which is the right hand side. All right, so that is the right hand side.